Hello everyone. Today we'll be going through very important topic of IGCSE mathematics, which is probability and conditional probability. A lot of students were facing problems and they send me questions also, so I'll be covering a lot of difficult questions in this video. So the thing which I want to mention in advance is that if you have not gone through the basics of probability, then first you need to go through the basics of probability and then come to this one for exam preparation, because these are the hard questions, the difficult questions which you for which you need basic knowledge of probability. So I'll be going through this one. After doing these questions, you will be able to handle the probability questions hopefully very easily. Now, first question is a drawer contains 4 pairs of black socks, 3 pairs of blues, 2 pairs of green, and 1 pair of yellow and 1 red sock. You know that probability questions are having very important wording. So if you notice here, they have used the word 1 red sock, and for the others they are using 4 pairs of black socks. This is plural. Similarly, this one, 3 pairs of blue and 2 green and 1 pair of yellow. For red, they are saying 1 red sock. So this is important. Then 2 socks are randomly selected without replacing any socks. What is the probability that A part is they are both black, B part, C part is also there? We will go through this. First, we need to understand the wording of the question, and we will understand, like for example, there are 4 pair of black socks, so we can write it as black, black, black and black, and these are 4 pairs, mean 8 socks are there in these, and then 3 pair of blue socks, so we can write blue, blue and blue, and adding this will be giving us 6 socks. And then there are 2 green socks, so we can take 1 green and another green, and this is adding up to 4 number of socks. And yellow is 1 pair, so yellow, if I take this color, so this will be yellow, and this will be 2 socks. And red, they are saying only 1 sock, so this will be only 1 sock, so this will be 1. I'm just circling to indicate that this is only 1 sock, and I'm just reducing the size. And this total number of socks, if we check the total number of socks, these socks are how many? These are 21 socks, so there are total 21 socks. So for A part, we need to find they are both black. So for tree diagram, I have just drawn a small diagram here. If I can enlarge this, this is the situation which we already have. So black, blue, green, yellow and red. So probability of getting black will be 8 out of total, which is 21. So I'm writing here 8 out of 21. 8 out of 21 will be probability for black. For blue, it will be 6 out of 21. Similarly, for green, there are 4 green, so 4 out of 21. Hopefully you are understanding. Yellow are 2, so 2 out of 21. And red is only 1 sock, so it will be 1 out of 21. Hopefully you got this as well. Now I'm just reducing a little to save the space, and this is the probability tree diagram which we have done. And I will shift this as well over here, and this is the detail of the question. We have not yet started the A part. So A part is what? A part, they are saying for A part, we can go through this. They are saying they are both black. So first should be black. For probability for first should be black is 8 out of 21, and for probability for second to be black is one less because one is gone, so 7 out of 20. We will be multiplying these two and we will be getting answers. So we can calculate this. 8 over 21 multiplied by 7 divided by 20 is equal to 2 over 15. So 2 by 15 will be probability of getting both black, and this is the A part which we have solved. Now for B part says they are both the same color. So same color can be, what can be the options for same color? It can be black and black. Second possibility will be green and green. And third possibility can be blue and blue. And fourth possibility can be, probability can be yellow and yellow. Yellow and yellow. So for black and black, we can have, like, for example, we have already calculated in A part, so I will copy from there. It will be 2 over 15. For green and green, there are 4 greens, so it will be 4 over 21 multiplied by 3 by 20. So these will be of same color, so we can calculate. This will be 4 over 21 multiplied by 3 over 20, and this will be equal to 1 over 35. 1 over 35. There are some students, they are saying that you are solving very slow. I'll request you to just speed up the YouTube video so that you can go through the video quickly. But there are a lot of students who want a little more slower, so I will be maintaining the pace. You can check for the speed of the video also. So for blue and blue, there are 6 blues, so 6 out of 21 into 5 out of 20, and this will be equal to we can write this as 6 over 21 and multiply by 5 over 20, and this is giving us 1 over 14. So 1 over 14 will be this one. So we got, so far we got 3. So yellow and yellow, also we can check yellow. There are 2 yellows, so 2 over 21 multiply by 1 over 20, and this will be 2 over 21 multiplied by 1 over 20 will be resulting to 1 over 210. So 1 over 210. So this will be the last for yellow and keep in mind red is not possible because red is only one sock. So I'm just putting cross here for red for your understanding so that you can know that where is the red sock going. So now this one I have reduced. Now we can add this one. So this will be, we can add all probabilities. So 2 over 15 plus this will be 1 over 35. 1 over 35 plus 1 over 14 plus 1 over 210. These are 4 probabilities which we can add, and this will be 2 over 15 plus this will be 1 over 35, and next will be 1 over 14, and for the next will be plus 1 over 210, and this is resulting to 5 over 21. 5 over 21 will be the answer for B part. A part answer we got 2 over 15, and B part answer we got 5 over 21. Hopefully you understood this B part as well. Now C part says one of the socks is a red one. So one of the red socks, there can be 2 options. The one option can be red and not red. So not red, I'm writing this and circling so that you can differentiate. And the second option can be not red, first one, and the second one red. So these are the two options which we can have in this situation. And now we can write for the probability of red. We already basically know there's only one source of red, so 2 over 21 multiplied by non-red are 20, so 20 over 1 is gone, so 20 over 20 plus non-red will be 20 over 21 into red will be 1 over 20. This will be the situation. We can cancel these 20s and we will get 2 over 21, and 2 over 21 will be answer for this part. Hopefully you understood this. This was the tricky question. And next question, if we go through question number 2, question number 2 says a virus is present in 1 in 250 of a group of sheep. To make testing for the virus possible, a quick test is used on each individual sheep. However, the test is not completely reliable. A sheep with the virus test positive is 85% of the cases, and a healthy sheep test positive is 5%. So if we draw a tree diagram, so we can take, like for example, this will be healthy and this will be unhealthy. We can take two options. This will be healthy, this will be unhealthy, and unhealthy we can take UH, and they are saying 1 in 250, this one 1 in 250 virus is present. So virus present is 1 out of 250, so we can take 1 out of 250 virus is present, which is we have taken unhealthy as case that virus is present, and virus not present will be 249 over 250. This will be the second option. Then we can take 85% will be, if sick mean this one, 85% chances that it is positive, so P and negative will be 5%, 15%, remaining will be 15%. So this option, and for this case we can take positive and negative, positive and negative, and they have mentioned as 5% cases, so 5% this will be positive and remaining will be 95%, so 95% will be negative in this case. So this is the tree diagram which I have drawn for this question. You can go through this tree diagram and this simplifies our issue. Now we will answer the questions, and A part, use the tree diagram to help to calculate the probability that a randomly chosen sheep will have the virus and will test positive. Will have virus and test positive will be which option? That is what we need to take. So we can take this route, will have virus and test positive will be this route. So if I write the probability for A part will be what, 1 over 250, 1 over 250 and multiplied by 85%, so 85. We can write percent this one, or we can write 85% like this one, and we can simplify. This will be 1 over 250 and multiplied by 85 over 100, and this will give us 17 over 5000. So 17 over 5000 in decimal we can write, decimal will be 3.4 into 10 to the minus 3, or we can write 0.0034. this will be in decimal format, and this one I will just move here. So this will be our A part. Now A part is done. We can go through B part, and B part says what's the probability that a randomly chosen sheep will have the virus and will test negative. Will have virus and test negative will be the second option, which we can take this and this. So if I write the probability for B part, this will be 1 over 250 multiplied by 15%. 15%, as you know, we can write like this, or we can write over 100, and this will be 1 over 250 and multiplied by 15%, and this is resulting to 3 over 5000. So we can write 3 over 5000, and in decimal this is giving us 6 into 10 to the minus 4, as I have adjusted in scientific format. So but you can change into decimal, which is 0.0006, and this is one A part, this is B part. We are done with two parts. And the C part says what's the probability that sheep will test positive. Sheep will test positive will be different roots, so we can take one root positive, this one, and the second root which we can take is this one. So I'm using different colors, you can identify. See, we will take both options. So first will be 249 over 250 and multiplied by 5%, or we can write 5 over 100, plus the other branch is 1 over 250 and multiply by 85%, or 85 over 100. We need to calculate this. It will be 249 divided by 250 into 5%, which is 5 over 100, and plus this will be 1 over 250 multiplied by 85%, or 85 over 100, and this is resulting to 133 over 2500. So 133 over 2500, and in decimal format we can check. This will be 0.0532, 0.0532. This will be our answer for second part. Hopefully you understood this. Now this is question number 3, and the question number 3 says two opera singers, Mario and Clarissa, both sing on the same night in separate performances. The independent probabilities that two newspapers X and Y publish reviews of their performances are given in the table. This is Mario's performance, this is Clarissa's performance. Probability of review in paper X, this is in paper Y, and these are the probabilities they were provided. We need to find ABC part. A part says if Mario buys both newspapers, find the probability that both papers review his performance. B part, if Clarissa buys two newspapers, find the probability that only one paper reviews her performance. Only one. In probability, you know, wording is very important, so they are saying only one. Now the next C part is Mario buys one of the newspapers at random. What's the probability that it has reviewed both performances? So for A part, Mario buys both newspapers. Both newspapers, find the probability that both papers review his performance. So both papers will be reviewing, that will be this one. We are talking about Mario. So this one is reviewed, X reviewed and Y reviewed. So we will be taking 1 by 2. We can write as 1 by 2 into 1 by 4, and this will be equal to 1 by 8. This is simple. A part is done. Then B part, we can go through. If Clarissa buy both newspapers, find the probability that only one paper reviews his performance. So if this is, for Clarissa, we are checking if this one is reviewing, then the other one is not reviewing. So we will have to take like 2 by 3 is reviewing, but why not reviewing will be what? This will be 3 by 5 not reviewing. So we'll multiply this by 3 by 5, and plus if this is not reviewing, this will be 1 by 3, and we will take 1 by 3 into other reviewing, that will be 2 by 5. And this one also we can calculate by the help of calculator. So it will be 2 over 3. Basically we can cancel 3 and 3. This will be 2 by 5. So we can write here 2 over 5, and plus this will be 2 over 15. So 2 over 15, and this is giving us 8 over 15. So we can write here answer as 8 over 15 for B part. Now for C part, Mario buys one of the newspapers at random. What's the probability that it has reviewed both newspapers? So reviewed both newspapers, we will be taking this one 1 by 2, this and this one, so multiply by 2 by 3, and plus if we will be taking reviewed this and this, so this will be 1 by 4 into, these are reviewed in all cases, and we have to take half of this, so because half are reviewed, so we can calculate this. It will be 1 by 2, 1 over 2, and this will be, we can cancel this. Basically this can be cancelled, and 2 1s are 2, 2 2s are 4, and in this calculation we can write 1 over 3, and this will be plus 1 over 10, so 1 over 10, and this will be resulting to 13 over 60. 13 over 60 will be answer for this C part. Hopefully you understood this question as well. Now the next question is a little tricky, which is this question 4. A and B part are easy, but C part is a little difficult. An office block has 5 floors: ground, first, second, third, and fourth. They are all connected by a lift. When the lift goes up and reaches any floor except the 4th floor, which is the top one, the probability that it continues to go up after it has stopped is 3 by 4. So probability of going up is 3 by 4. This is what we got from here. And the second portion is when it goes down. So when it is going down probability is what? Except the ground floor, because ground floor is the base, is the last one. Basically we can take this as ground floor, this one as 1 2 3, and this will be the 4th floor. So it will be the probability that it continues to go down after it has stopped is 1 by 4. So probability for going down is 1 by 4, and keep in mind ground floor, there's no further down, so from ground floor to up will be the only option available. From ground floor to down option is not available. Similarly from 4th floor up option is not available, only down option is available. So this is important. Ground floor to down is not available, and 4th floor to up is not available. That we will utilize. The lift stops at any floor that is it passes. So you have to stop at all floors. The lift has gone down and is now at first floor. So first floor the lift is there. Calculate the probability of these events. A part, its second stop is the third floor. So second stop is third floor, which will be taking. A part, it is at 1, so from 1 it will be going to second floor, then third floor. So this will be, it means it has to go up and again it has to go up. So 2 times up it will be going, and for going up we know the probability is 3 by 4. So this will be what we will write here, 3 by 4 and 3 by 4 because it is going up. So this probability will be what, this will be 3 by 4 multiplied by 3 by 4. So this will be 9 by 16, and 9 by 16 will be answer for A part. Now for B part says, its third stop is the fourth floor. So what are the options? From first floor it will be starting, so first to second and then third, and then it will be fourth floor. These are the options available. So it will be going up, up and again up. So we can check the probabilities, and for the up we are having 3 by 4, so 3 by 4 and 3 by 4, and we can write the probability, which is 3 by 4 into 3 by 4 into again 3 by 4, and this will be 27 over 64, and this one will be the probability for third floor is third stop is fourth floor. So this one also done. Now for C part is difficult, and you have to be careful and understand this C part very carefully. It says its fourth stop is the first floor. So fourth stop is first floor. So what are the options which we can consider? So it can move from first floor to second floor, second to third floor, third to again second floor, and second floor to first floor. We have to start from first floor in every situation, and we have to stop at first floor in all the situations. So what can be the other possibilities? It is starting from first floor and going to the second floor, coming back to the first floor, going to the second floor, and then going to the first floor. This is another option which we can have. Third option can be first floor to second floor to first floor again, and then it goes to the ground floor, and from ground floor to first floor. So, and one more option it can have is what? First floor to goes down to ground floor, and then ground floor to first floor, then goes to second floor, and then comes back to first floor. So this is also possible. I'll increase the space, this one, so that we can write in between also. And the one more option is possible from first floor to ground floor, and ground floor to first floor, again ground floor, and again first floor. So these are the 5 different options which are available to us. So wherever it is going up, we will be taking 3 by 4, and going down we will be taking 1 by 4. So from first, I'm focusing on this one first. I'll be writing for this one. So first to second will be 3 by 4 because going up. This one also 3 by 4 going up, This is going down, so this will be 1 by 4. This is going again down, and this will be 1 by 4. And we can write here for these probabilities like 3 by 4 into 3 by 4 into 1 by 4 into 1 by 4. And then we will calculate this. Later on we can calculate. We can first write all the probabilities. So from first floor in this second line, first to second will be 3 by 4 because going up. 2 to 1, second to first floor will be 1 by 4. Going down, 1 to 2 will be going up, so 3 by 4. Second to first floor will be 1 by 4, and the probabilities we can write 3 by 4 into 1 by 4 into 3 by 4 into 1 by 4. Now for this third one, we can write from first floor to second floor will be up, so 3 by 4, then down 1 by 4, then again down will be 1 by 4, and from ground floor to first floor it's going up, but probability will be 1. Why not 3 by 4? Because it is having only one option, that it can move from ground floor to first floor. It's having only one option, so we will be writing here 1. This is what you need to understand. Then from first floor to ground floor, this will be down, so it will be 1 by 4. And then from ground floor to first floor, again the same situation, it is having only one option, so we'll take probability 1 here. And from first to second floor, going up will be 3 by 4, and going down will be 1 by 4. And we can write the probabilities. This will be 3 by 4 into 1 by 4 into 1 by 4 into 1, and this will be 1 by 4 into 1 into 3 by 4 into 1 by 4. Hopefully you are following whatever I'm saying. So for this last option, from first floor to ground floor, it's going down, so it will be 1 by 4. Ground floor to first floor, as we discussed in above two cases, this one and this one, it will be probability will be 1 because there is no other option available, so it will be 1. Then from first to ground, it will be going down, so 1 by 4, and again ground floor to first floor, as I explained, it will be probability as 1. And this we can write 1 by 4 into 1 into 1 by 4 into 1, and this will be the probability. And I will just reduce the size of this whole thing and shrink here. And now we can solve this. This will be what? This will be 9 over what? 4 times 4 raised to power 4 will be what? This will be 256. So 9 over 256 for this one. And then this is also 9 over 256, this one. And then third one is 3 over 64, and the fourth one will be 3 over 64, and this last one will be 1 over 16. So we got all the 4 probabilities, and now we can add the probabilities. So 9 by 256 plus 9 by 256 plus 3 by 64 plus 3 by 64 plus this will be 1 over 16, and we can add all these probabilities. So this will be 9 over 256, and then plus 9 over 256, and then plus 3 over 64, then again plus 3 over 64, and plus 1 over 16. This will be resulting to 29 over 128. 29 over 128. This will be the final answer for this C part. Hopefully you understood this. This is a little tricky question. You will have to go through this at least 2-3 times and understand specifically. Part C is a little difficult for this question, but hopefully I've tried my best to explain as much as I can. And this is question number 5. Question number 5 says 6 small plastic tiles are placed in a bag and jumbled up. Each tile has a single letter on it, the letter being B, O, and Y. There are 2 B's, 2 O's, and 2 Y's, and we need to answer these questions. A part says if one tile is taken out one by one without replacing any letters, and the letters are placed in order, show that the probability of obtaining each of the following words is 1 by 15, this one and this one. And for B part, if 2 letters S are put in the bag from the start, what's the probability that after 4 tiles are taken out, the word BOYS is not made? As mentioned in the question, there are 2 B's, 2 O's, and 2 Y's. So situation we can understand there are 2 B's, 2 O's, and 2 Y's. So it means total are 6 options available. So for A part, we can say we need BOY letter. So we require this one, B, O, and Y. We will check the probabilities for this. So probability of getting B will be 2 out of 6, and next 1 is gone. So for O it will be 2 out of 5, and for Y it will be 2 out of 4. And we can write this 8 out of 120, which we can simplify. 8 divided by 120 will be equal to 1 over 15. So 1 over 15 will be the answer for A part. Hopefully you understood this. Now for this is A part 1, A part I. So I, the second part says YOB. So we can check for Y, O, and B, and the probability for Y will be what? 2 by 6, and O will be again 2 by 5, and this will be 2 by 4, and this will be same as 1 over 15 as we have already calculated in I part, and this will be our answer for I. Now we can go for the B part, and B part says if 2 letters S are put in the bag from the start. Now what is the probability that after 4 tiles are taken out, the word BOYS is not made? So BOYS is not made. So we will take complement, because not made we can take as 1 minus made. So 1 minus letter BOYS. So BOYS probability for this we will be taking complement, mean 1 minus that. So we will be getting not made. So probability for B will be, now there are 6 plus 2, 8 letters. So it will be 2 by 8, and next will be 2 by 7. So we can take 2 by 7, and next will be 2 by 6 and 2 by 5, and we can calculate this, and this will be 1 minus we can write it as basically 2, 4, 8, and 16. So we can write 16 over 8 multiplied by 7 multiplied by 6 multiplied by 5, and bracket we can close, and this is 104 over 105, 104 over 105. This will be the answer for B part. We are done with the question. Hopefully you understood this. Now we can move to the next question, and this question is also a little tricky. A box contains 5 clearly different pairs of gloves. Carol is in a hurry and randomly takes out two gloves without replacing any gloves. What is the probability that the gloves are both right-handed? So both right-handed, what will the probability? So we can understand the situation: right glove, right, and right. So these are right gloves, and left, and left. So these are 5 left gloves. So probability for this one, like for example this matching with this, these are the two properly matching gloves, is 5. This is having now 5, right? So probability for first right glove will be what? This will be 5 out of, we have total 10 gloves, 5 this one and 5 this one. So choosing this R is 5 out of 10, because there are 5 R's and total gloves are 10. So we are writing 5 out of 10. And for the next respective L, choosing L will be, this will be for the next R, we can take 4 over 4, remaining will be 4, so 4 over 9. So both right-handed, because we are choosing both right-handed, we are not choosing left-handed. So for first one will be 5, for the second R will be 4 out of 9, and this will be equal to 20 out of 90, and which we can cancel zeros, and this will be 2 by 9, and this will be answer for A part. Now for B part, it says the gloves will be a right hand and a left-handed gloves. Right and left-handed gloves. So it can be two situations. It can be right left and it can be left right. So we'll be writing the probabilities and adding them. So probability of first right we know is 5 by 10, and the first left will be 5 by 9, because all left are there. So and next will be left, which is 5 by 10, and the right will be 5 by 9. This will be the probability, and we can add, this will be 25 by 90 plus this will be 25 by 90, which we can write as 50 over 90 and cancel zeros, and answer will be 5 by 9. This will be the answer, and we can reduce the size to fit, and this will be our final answer for this B part. Now we can go through the C part, and C part says they will be matching pairs. So matching pairs, to understand the matching pairs, what we can do, we can make pairs right, and right. So there are 5 right, and there are 5 L, 5. So only this one, if we are taking this will be what? They are saying they will be a matching pair. So one out of, for this one, matching pair will be this. So R, for example, R we have already taken. We have taken this, and now we have to match it, and from which we will be matching. We will be matching these 4 and from these 5, because this R we have already taken. So remaining are 9. So out of 9 we have to choose 1. So probability of choosing this 1 will be 1 by 9. So our answer will be 1 by 9. Hopefully you understood this C part. This was a little tricky, but I have tried to explain you graphically, and hopefully it's clear now. Question number 7. A new technique is 80% successful in finding cancer in patients with cancer. If cancer is found, a suitable operation has 75% success. So suitable operation we can draw side by side, like for example this one. So cancer and no cancer. So 80% cases are with cancer, so this will be 80% and this will be 20%. Remaining one, next they are saying 75%, so operation will be 75% successful. So we can take successful as S and unsuccessful as U and S, and 80%, basically 75% is successful, so 75% here, and this will be remaining will be 25% will be unsuccessful. Now in next situation is what? First time it is attempted. If this operation is unsuccessful, it can be repeated only twice more with success rate of 50. So this success will be 50%, and unsuccess will also be 50%. So this is successful and unsuccessful. So one more time we can apply this procedure, and this will be next will be 25%. So successful, unsuccessful, this will be 25%, and this will be 75%, and this will be our tree diagram which we will be following for our answers. And I'm just keeping here for tree diagram for reference, and we can go through a part. What is the probability of a patient with cancer being cured from the first operation? So from the first operation being cured will be this one, so we can write A will be 80% multiplied by 75%, and it will give us 80% multiplied by 75%, and this gives us 3 by 5, which is in decimal format 0.6. So 0.6 will be our answer, and this will be our final answer for A part. Now for B part says being cured from the third operation. So for third operation, which option we will be taking? We will be taking this route, and then we'll be taking this route. So this will be we can take 80% multiply by 25% multiply by 50% multiply by 25%, as I indicated in the tree diagram. So the same route we are taking 80% multiply by 25% multiply by 50%, and then multiplied by finally 25%, and this will give us 1 over 40, which we can write 0.025. This will be answer for B part. And next we can do the C part, and C part says, if we go through the C part says being cured. So cured is which root? Cured is 80%. There are different cured roots. So like for example, this is also cured root, so we will take this. So it will be 80% into 75%. This one is cured root. The second cured root is this one. This one, 1, 2, 3. This one is cured root. So we will be taking, this will be 80% into 25% into 50%. This is second cured root. And there is a third cured root as well, which we can take this and this one also. So it will be what we can take it as 80% multiplied by 25%, 25% multiplied by 50%, and multiply by 25%, and we will reduce the size according to our requirement here. And now we can add this one. We can write it as 80% into 75%, and bracket close, plus we can write 80% and into 25% into 50%, and bracket close, and plus the last one will be 80% and multiply by 25%, and then multiply by 50%, and then last 25% bracket close, and this is resulting to 29/40. So 29/40 will be our final answer for this C part. You see that this is a little tricky, but we are done with this question. Now we can move to the question number 8. If a clock is slow, it shows a time that is earlier than the correct time. If a clock is fast, it shows a time that is later than the correct time. A school has unreliable clock. The probability is that the clock becomes 1 minute fast or slow is in any 24-hour period are shown in this table. If it is fast, then probability is 1/2, no change, probability 1/3, and slow probability is 1/6. If the clock is set to correct time at noon on Sunday, find the probability that these events. So A part, the clock is correct at noon on Tuesday. So we started on Sunday. So if we start on Sunday, there will be Monday and Tuesday. So we can take this one as Sunday, then next will be Monday and Tuesday. We can, so on Tuesday we need to check what will be the probability. Okay, so these are 3 events. So we started. What can be the options? Option can be that first is it's becoming, like, for example, 1 minute fast. So first of all, we will draw a tree diagram so that we can understand it properly. So what I will do, I will reduce this and move it here, and we can draw a tree diagram. And I have just drawn a tree diagram here. If we understand the situation, we can understand like this. So it can be, this is on Sunday, and on Monday this will be situation, and Tuesday will be this situation. And if it is it can be fast, it can be no change. So no change, I'm writing N, and slow, I'm writing S. So the probability will be, this will be 1/2, and no change is 1/3, and slow is 1/6. Similarly, it can be fast, it can be no change and slow, fast, no change, and slow, fast, no change, and slow on Tuesday. So the probabilities will be same. So 1 by 2, 1 by 3, and 1 by 6. 1 by 2, 1 by 3, and 1 by 6. 1 by 2, 1 by 3, and 1 by 6. These will be the probabilities. Now we need no change, basically correct time. So correct time can be this branch, fast and slow. So 1 minute gain, 1 minute loss, so it will be no change. So we can take this probability as fast and slow, so it will be 1 by 2 into 1 by 6. This can be one option. The second option, it can be no change, no change. So no change, no change will be this option, and we can take it as 1 by 3 into 1 by 3, and this is a part which we are solving. And the third option can be, it can be 1 by 6 slow and fast. So slow and fast, so this will also be no change. So we can take 1 by 6, 1 by 6 into 1 by 2, and now we can calculate. This will be 1 over 2 multiply by 1 over 6, and then we will be 1 over 6, and then we will be adding, plus this will be 1 over 3 into 1 over 3. We can directly write 1 over 9, and then plus we can write 1 over 6 into 1 over 2 will be 1 over 12. So we can write 1 over 12, and this will be adding up to 5 over 18. So 5 over 18 will be our answer for A part. Hopefully you understood this. Now A part is done. B part says the clock is not slow at noon on Wednesday. So we have to consider on Wednesday also. So next Wednesday will be like this one. So not slow. So we can take the complement. We can, if we take 1 minus slow, that will give us the answer for not slow. So for slow, there are different options which we can take. So what I will do, I will remove these highlights so that we can understand properly. And for slow, we can take different options. First option we can take is fast, slow, slow, and that will be like, we will be extending this for the Wednesday also. So each one will be having 3 options. So like for example, if I try to explain, like for example, fast, no change, and slow will be for this branch, but we will not be taking, because all these will be too fast, so it will not be same time. So we are there will be no slow in this branch, so we are ignoring this branch. We are ignoring this branch. Next branch also, this branch also we are ignoring, because there will be no slow in this branch. Next we can take next branch, which is fast, slow, and slow. So first option which we will be taking, I will write here, first option we will take fast, slow, and slow. So fast, slow, and slow will give us one option, and plus other options can be what? No change, no change, and slow. So if I remove these brackets, so I will be just writing FSS, and next will be no change, no change, and slow. Next what we can take is no change, slow, and no change. So no change, slow, and no change. This will be slow, this will be slow, net will be slow for these. Further options we can take, and further option will be no change, slow, and slow. And what else we can take? We can take slow, fast, and slow. plus we can take slow, no change, no change. And what else we can take? We can take slow, we'll add here slow, no change, and slow. And one more thing we can take is slow, slow, and fast. So further we can take slow, slow, no change. And the last one we can take is slow, slow, and slow. So these are 1 2 3 4 5 6 7 8 9 and 10 options which we can take. And now we can write the probabilities for all of these. And what I will do, I will make a gap and write the probabilities in between these. And this one will be we can write it as fast will be 1 by 2. So 1 by 2 into 1 by 3. This will be slow, will be 1 by 6, sorry. So this will be slow, it will be 1 by 6 into 1 by 6. So we can write it as 1 over 2 multiply by 1 over 6 into 1 over 6, and this is giving us 1 over 72. So I will write for this one 1 over 72. Now next we will write no change 1 by 3 into 1 by 3 into slow, which is 1 by 6. So this will be 1 over we can check this one, 9 into 6 54, so 1 over 54. So we can write 1 over 54. We can write here 1 over 54 plus next is no change, which is 1 by 3 into slow 1 by 6 into no change, which is 1 by 3. So this will be 1 over 54 again. So I will erase this. I will write here 1 over 54. Hopefully you are understanding. Next is no change, which is 1 by 3, and then slow and slow. So 1 over 3 into 6 into 6 will be resulting to 108. So we can write 1 over 108. So we can write here 1 over 108. Hopefully you are understanding. Then slow, which is 1 by 6, and fast, which is 1 by 2, and again 1 by 6. So this will be 1 over 72. So we can write here 1 over 72, 1 over 72, this one. Then slow, which is 1 over 6, no change, 1 by 3 into 1 by 3. So this will be 9 to 6 will be 54. So it will be 1 over 54. So we can write here 1 over 54 plus now we can take this one, which is okay. Now we can go for slow, which is 1 over 6 into no change, which is 1 over 3 into 1 over 6, and we can write this 36 into 3. So 36 into 3 will be resulting to 36 multiplied by 3 will be resulting to 108. So 1 over 108, we can write here 1 over 108 plus slow will be 1 by 6 into 1 by 6 into fast will be 1 by 2. So 36 into 2 will be 72. So it will be 1 over 72. Hopefully everything is properly calculated. So slow is 1 by 6. So we can write 1 by 6 into 1 by 6 into no change, which is 1 by 3. So this will be 36 into 3 will be 108. So we can write 1 over 108. So 1 over 108 plus slow, all three slow will be 1 by 6 into 1 by 6 into 1 by 6, 36 into 6. So it will be 36 into 6 will be 36 multiplied by 6 will be 216. So we can write 1 over 216, 1 over 216. This one, yes. So now we can add all these probabilities and we will get answer. So we can write it as 1 over 72 and plus we can write 1 over 54 and plus 1 over 54 again, and then plus 1 over 108 and then plus 1 over 72, and next will be plus 1 over 54 and plus we can write 1 over 108, and next will be plus 1 over 72 plus 1 over 10, I think so, limit of calculator is over. So last two numbers we will add later. We will calculate this. This one is we need to remove this one here. So we can remove this one and calculate. This will be 25 over 116 plus we will take 1 over 108 and the last one is plus 1 over 216, and this is resulting to 7 over 54. So 7 over 54, this will be the this will be slow. This is for slow. We have taken the probabilities. Now we can take 1 minus slow, and 1 minus slow means 1 minus 7 over 54, and we can take 1 minus answer. This will give us 47 over 54. So 47 over 54, this will be our final answer. And this was a little tricky question. We have done this. This is tree diagram. First of all, we have drawn tree diagram where I have shown the probabilities. Then A part was simple. We need to check for different options. There were 3 options and for correct time, and then B part they were asking for not slow, so we have taken complement 1 minus slow, and this is the answer. Hopefully you understood this. Now we can move to the next question, and next question is question number 9. Question number 9 says the probability that a washing machine will break down in the first 5 years of use is 0.27. So we'll draw the probability for this one. So we can take this one for washing machine, W for washing machine, and it breaks and not breaks. We can take, and the probability they are saying is 0.27, and the other one not breaking will be 1 minus 0.27, which we can take as 0.73. And next they are saying the probability that a television will break down in the first 5 years of use is 0.17. So for the television also we can draw the probability. This one for T we can draw is 0.17. So 0.17 is break and this is not break. So not break will be 0.83, which is 1 minus 0.17. This is done. Now next what we can do is I will just reduce the size, and then A part. Then they're saying Mr. Khan buys a washing machine and a television on the same day. By using tree diagram or otherwise, calculate the probability that in the 5 years after that date, A part, both the washing machine and television will break down. So both will break down. A part. Break down means we will take this one and this one. These two options we will have to take. So it will be 0.27 multiply by 0.17, and this will be giving us 0.27 multiply by 0.17 is equal to 0.0459. This will be the probability for both broken. Then at least one of them will break down. So at least one of them break down. We will take 1 minus no breakdown. 1 minus no breakdown. We can take this probability, which is like complement. So 1 minus no breakdown will be 0. We can take this branch, this one, and this one. So it will be 0.73, 0.73 multiply by 0.83, and this will be equal to 1 minus 0.73 multiply by 0.83. Decimal we missed over here, and this is the decimal, and this will be resulting to 0.3941. 0.3941. This will be the probability for at least one of them will break down. Question number 10. A box contains 2 white balls and 5 red balls. A ball is randomly selected and its color is noted. It is then put back in the box together with 2 more balls of the same color. So now till here we have to draw the tree diagram first so that we can understand the situation. Then we will be going through the next part of the question. So if we draw tree diagram, so there are 5 red balls and 2 white balls. So 2 types of balls. One is white and the second one is red ball. So these are total are 7, 2 plus 5, so total are 7. So we can write this is 2 by 7 and this will be 5 by 7. Now if first ball is white, then they are saying it is then put back in the box together with 2 more balls of the same color. So if first ball is white, so 2 more white will be inserted in the box and it will become 4. So 4 out of 9 for white. And if it is, for example, red ball, so we will be inserting red ball, so it will be in that case it will remain same, so it will be 5 out of 9 because we have inserted 4 balls. Now if it is red ball, then white will remain same, so it will become 2 by 9 because we are inserting 2 red balls. So red balls will become 7, so 7 out of 9 will be this. So this will be the situation if we are putting 2 more balls in it. And this is our tree diagram, which I am just keeping here so that we can refer during a question. Now next part of the question, A part. If a second ball is now randomly taken from the box, calculate the probability that it is the same color as the first ball. So second ball of the same color, A part, we can see A part same color will be, can be white, it can be white and white, or it can be red and red. These are the 2 options for the same color. So white and white will be this route, white and white, and red will be this route. So these are the 2 routes which are available. So white and white will be 2 by 7 multiply by 4 by 9, and red will be 5 by 7 multiplied by 7 by 9, and we will be adding these 2 First we'll multiply 2 over 7 multiply by 4 over 9, and this is equal to 8 over 63, 8 by 63, and the second will be 5 over 7 multiply by 7 by 9, and this will be 5 by 9, so we can write here 5 by 9. Now we'll be adding these two, and by adding we will get 8 over 63, this will be adding 43 over 63, so 43 over 63 will be answer for part A, which is done. For part B, what is the probability that the second ball is different color from the first ball? So now we are having different colors, so one will be white, the second one will be red, and if first is red, the second one will be white. These are the two options available. So if first one is white, it will be 2 by 7, and second is red, will be 5 by 9, and if first one is red, then 5 by 7, and second, so this will be 2 by 9, this will be the option. And now we can solve, it's basically same but different settings. So 2 over 7 into 5 over 9, and this will be equal to 10 over 63. So 10 over 63, this will also be 10 over 63, and by adding both we will get 20 over 63, and this will be answer for B part. A part, B part we have done. Now we can go through C part, and C part says find the probability that the second ball is white. So second ball should be white is what option? It can be white and white, or it can be red and the second one is white. So these are the two options available to us. So we can take white. First white will be 2 by 7, and second white will be 4 by 9, and this will be equal to 8 by 63, and for the first red it will be 5 by 7, and white, second white will be 2 by 9, and this will be 10 over 63, and if we combine these two we will get 18 over this will be 18 over 63, or which we can simplify to 2 over 7. This will be our probability for C part. Now we can reduce the size so that we can make the space for the next part also, and this is the concise ABC part. And now we can do the D part, and D part says if we go through D part says Nick says after the first ball is taken out, if we then add to the box any number of boxes of the same color as the first ball, the probability that the second ball is white will not change. Is this statement true or false? Justify your answer. So probability of second white we need to check. Probability of second ball to be white will be if first ball is white, we will take the probability of first ball white, and the second ball we will add any number of boxes, so any number of balls. So we will add, like for example, x balls we are adding, so it will become 2 plus x, and total will become 7 plus x. So if this will be the situation. And second situation can be that first ball is red and the second one is white. So we have taken this one as white, and then we have added white balls, right? And now we are taking red and then we will add. So this red probability will be 5 by 7, and into we will be not adding in this, but total will be added. So 7 plus x, because red we are not adding. So this is white, so we are adding this 2 over 7 by 9. Hopefully you are understanding this. Now we can, this one I just written for your explanation. I will erase this, and we will get, this will be, we can simplify. This will be, from here we can take common 2 over 7 into 7 plus x. We can take common from this one and this one. Two terms are there. So from these two terms I have taken 2 over x. So what we are taking common? We are taking this part and this part common, and from here we have taken this part and this part common. So remaining part I'm just writing here. This will be 2 plus x plus 5, and we can rewrite it as what? We can rewrite it as 2 over 7 into 7 plus x, and this will become 7 plus x, and we can cancel this, and the probability, net probability, will be 2 by 7 again. So hence the statement is true. Hence the statement is true. So this is what we are done with this question. Now we can move to the next question, and the next question says the probability of bullet train to Tokyo. Question number 11. The probability of bullet train to Tokyo station arriving late is 0.3. The probability that it arrives on time is 0.6. And what is the probability that the train is early? And these are the questions. Before going to the questions, we can discuss the tree diagram. What will be the tree diagram? We can understand tree diagram. We can take the three options, and these will be the three options which we can draw. And first option will be, like, we can take early. So early and on time and late. So these are three options, and they are saying to arriving late is 0.3. So this probability is 0.3, and arriving on time is 0.6. So this is 0.6, and the remaining will be what? Remaining will be 0.1. So these are the probabilities. Then we can check for the next one also. We will be taking like early, on time and late. Early, on time and late. And for this also we can take three options: early, on time and late. And for this also there will be three options which we can consider, and those will be also early, on time and late. So according to the requirement we can complete this tree diagram, but all the options probability will be same for all options. Like this will be 0.1, this will be 0.6, and this will be 0.3. So I'm not completing the whole tree diagram, but hopefully you got the concept, and I will keep here for reference. If required, I will complete this also. And here is the part A, and part A says what? Part A says is early. So early will be this one. So what's the probability that train is early? So early is this one, which we can take 0.1. So this is simple. For A part we can write 0.1 will be our answer. Then for B part is not late. So not late will be 1 minus late. So we can take 1 minus late, that is 1 minus 0.3, which is equal to 0.7. So 0.7 will be the answer. So this is A part answer, this is B part answer. Now C part says is on time for 2 days in a row. So on time. So on time will be this root, and we can take this one also as 0.6. So it will be, for C part, we can write 0.6 into 0.6, which is on time, and this will be giving us 0.36, and this will be the answer for C part. And for D part says is late on Fridays. Is late on Friday but not late on the next 2 days. So Friday it's late. So first one is late. We can take this option. This one late but not late. Not late can be not late is here. B part we have already calculated, which is 0.7. So we can utilize that one. So D part will be late on Friday but next 2 days not late. So 0.7 into 0.7, from where we have taken 0.7, as I told in B part that we are taking 1 minus late, so which is not late. So we can calculate this. It will be 0.3 into 0.7 and this one, and multiply by 0.7, and this is giving us 0.147, and this is the probability for this, which we have calculated. D part, I'm just adjusting the size, and this is our answer. So we can take this as answer as D part. Now for E part, which is a little tricky. E part is saying is late once over a period of 3 days in a row. So 3 days in a row it is late. So what we can do, we can take, this is E part, we can take early, so late once, so we can take early and late, and then we can take early, on time, and late, early, late, and early, and then we can take early, late, and on time. So for early we will be taking the same, these options, and then we can take on time options. On time options, we can take on time first, and then we can take early, late, and on time, late, and late and early, and late and on time. Then we can take the third option, that can be late, and it can be early, late, early and early, then early and on time, then we can take on time and early, and then we can take on time. So these are the 4 options which we can take. I will adjust the size, and these are the 4 options which we can take. Now we can calculate these options. So for early and early, which is the first option basically, so we can take early is 0.1, so 0.1 into 0.1 into 0.3, so it will be 0.1 into 0.1 into 0.3, and this will be this will be equal to 0.003. So I will write 0.003. Okay, this one I will keep as it is. Then early, which is 0.1 into on time, which is 0.6 into next one is late, so late is 0.3, so this will be 0.018, and next one we can take early, which is 0.1. for early we are taking 0.1, for late we are taking 0.3, so this will be 0.3, and then early 0.1 again, and this will be 0.1, and late will be 0.3, and on time will be 0.1. Now on time is 0.6 basically, so we can take this 0.6, and if we multiply we will get 0.003, and this will be 0.0018. So these are basically the options for this one. I'm just keeping here so that you can figure out, and I will move this one a little over here, and I will draw a line also so that you can figure out. And now we can move this also a little over here, and I will draw a line also here so that we can separately calculate, and then we will be adding. Now we can calculate for on time in 0.6. So 0 on time for all four, I'm writing 0.6, and multiply by early will be 0.1, on time will be 0.6, late will be 0.3 and 0.3, and late will be 0.3, then late 0.3, then early will be 0.1, and last will be on time will be 0.6. And then we can reduce the size to make the space over here, and then we can adjust this one. This will be 3 into 6 will be 18 into 1, so 0.018, and this will be 36 into 3 will be 108, so 0.108, and this will be 18 and 0.018, and the last one will be 0.108. This is how we are getting. We will be adding this later, but we need to write this probabilities also for this last step. Late will be 0.3, so we can write 0.3, 0.3, 0.3, and 0.3. Multiplication for all four. Early will be 0.1, so 0.1, 0.1, and on time will be 0.6, so 0.6 and 0.6. And then we can calculate early, which is 0.1, and on time, which is 0.6, then early again 0.1, and on time will be 0.6. And now we can just shrink it a little over here to make space for the other numbers also. So next is what? Next we can, this one was 0.1, okay, this is multiplication sign, and next this will be 0.003, and this will be 0.018, and this will be 36 in 1, so 0.0, this will be 0.18 also, and this will be 36 into 3 will be 0.108. Now I will be shrinking a little this whole thing so that it will fit in properly over here, and now we can use this. We will be adding this all, and we can use calculator for this one. So it will be 0.003 plus this will be 0.018 plus this will be 0.003 plus this will be 0.0018, and this will be resulting to 0.003, 0.18, 0.003, and 0. I think so. We have done some mistake. I will check again. 0.003, 0. This should be 10, this one. And this is resulting to 0.042. 0.042 will be for this sum, and the other one we can add 0.018 plus this will be 0.108 plus next will be 0.018 plus this will be 0.108 and this will be resulting to 0.252, 0.252, and the last one we can add, this is 0.003 decimal, we missed this one, and next is plus 0.018 plus 0.018 plus last will be 0.108 and this will be equal to 0.147, 0.147. Now we need to add decimal. I'll write properly this one, 0.14. okay, so we need to add all these three. So 0.042 plus 0.252 plus 0.147 and this will be 0.042 plus 0.252 plus 0.147. This will be resulting to 0.441, 0.441. This is the final answer for this question. It was a little tricky question. The E part is it's confusing also, so you should go through these type of questions for your exam practice. Question number 12. Two six-sided dice have the letters U, V, W, X, Y, and Z on the faces with one letter on each face. If the two dice are thrown, calculate the probability that they show the two vowels. So two vowels we will show. How we will show two vowels? A part we will be solving. Vowels, you know, these are the vowels which they have indicated. A, E, I, O, U will be taking as vowels. So there are total 1, 2, 3, 4, 5 and 6 letters, and if we check from these 6 letters only U is the vowel, so we can take, it will be 2 times two dice are thrown, so it will be 1 by 6 for first die and 1 by 6 for the second die. Or we can, for understanding, I'm writing this one will be U and the second one will be also U, so probability for getting U is 1 by 6 and for getting U is 1 by 6, so this will be equal to 1 over 36. This will be simple answer for A part. And B part says a vowel and a consonant. So there are two options. One is vowel, and so for vowel I'm writing V, and for consonant it will be C. So it can be this option, or it can be first it can be consonant and vowel. So these are the two options which will be taking, and we will be adding those two options, and this is B part. So for vowel, for getting vowel it will be 1 by 6, and for getting consonant it will be remaining or 5, so it will be 5 by 6. Hopefully you are understanding. Then this will be, consonant will be 5 by 6 and vowel will be 1 by 6, and we will be multiplying this. It will be 1 over 6 and multiply by 5 over 6, and this will be plus 5 over 6 multiply by 1 over 6, and this will give us 5/18. 5/18 will be probability for this B part. Hopefully you understood this. This was a simple straightforward question. Now this one is question number 13, which we can go through. This question says Gina and Iona are taking part in ski instructor test. They are only allowed one retest if they will fail the test. So if they will be failing test, they will be allowed to take one more test, but only one retest option is available. Their probabilities of passing as are shown below. So these are the tables. So this is for Gina. It will be for passing first test is 0.7, passing second test is 0.9, and for Iona it is 0.4 passing first test, and passing second test is 0.6. Now we can draw a tree diagram for separate for Gina. So Gina is having first test passing is 0.7. so pass first test will be, this will be pass, and this will be 0.7 probability. So failing will be 0.3. so we can show here fail will be 0.3. and next, if she passes in on second test, so passes second test will be in this case, this will be second test pass and second test fail. So passing second test is 0.9, and failing this will be 0.1 remaining probability. So this will be the tree diagram for Gina, and similarly we can draw for Iona. And if we take for Iona, it will be pass and fail. So passing first test is what? Passing first test is 0.4. So 0.4. So remaining will be 0.6 will be the failing probability. And now if she is failing, she will be going for the second option, and this will be probability of passing and failing. We can check, and this will be for the second time passing is 0.6. so we can take this as 0.6, and this one will be 0.4. so this is how we can draw the tree diagrams, and I will be adjusting this, and I will be putting it here, and we will be referring to this one. Now we will be answering the questions. These probabilities are independent of each other. Calculate the probability that A part Iona becomes a ski instructor at the second attempt. So for the second attempt she becomes instructor, mean she is failing first test and then passing the second test. So for A part, and this is for Iona, so I will write here Iona, and pass second attempt. Okay, so second attempt will be which route? This will be fail first attempt and then pass second one. So we can show this one will be the branch which is required. So we will be writing 0.6 multiplied by 0.6, and this will be equal to 0.36. This will be the answer for A part. Now for B part, if we go through B part says Gina passes at her first attempt whilst Iona fails her first test. So Gina passes first test will be which option? Gina passes first test is this route, and we can take Gina will be pass. So for Gina this is pass, and for this one Iona whilst Eona fails her first attempt. So failing first attempt will be, for Eona it will be 0.6, this one. So we can take 0.6. So for Eona this will be fail. So we can take probability for Eona failing will be 0.6, and for Gina passing is 0.7, and we will multiply these two, and this will be equal to 0.42. 0.42 will be probability, and this is our B part which we have answered. Now we will be going for the C part, which is a little tricky, and it says only one of the girls becomes ski instructor, assuming that a retest is taken if the first test is failed. So what can be the probabilities? So probability of first will be that Gina is failing first test but passing the second test, and in Eona is failing both tests. So because one is passing at a time, so this can be the probability, and we will be multiplying these two probabilities. And the second option can be Gina is failing both attempts and Eona passes her second attempt. So it will be like this one. So in this case Gina passed this one, Gina passed in her second attempt, and in this one Eona passed her second attempt. Now first attempt also we can take into consideration. If if Gina is passing in her first attempt, this will be passing, and Eona will be failing in both attempts because one of them is passing, so this is failing. And the second, the last one can be, this is passed, and last can be Gina is failing both attempts, but Eona is passing her first attempt. So this will be the pass option we will be considering. So these are the four options we will be considering, and we have to write the probabilities for all these four options, and we can write these options as, like, for example, here we can write their probabilities. Gina fail probability is 0.3, so this will be 0.3, which we have taken from here. And then Gina pass probability is 0.9. Fail first and then pass will be which route? This will be fail then pass. So 0.3 into 0.9 will be the option, and for Eona fail and fail will be 0.6 and 0.4. So we will take 0.6 into 0.4, and then for the Gina fail will be this route, which is 0.3 into 0.1. So we'll take 0.3 into 0.1 into Eona fail and pass. So fail and pass will be this route, which we have 0.6 into 0.6. So we can take 0.6 into 0.6. Now Gina pass in her first attempt will be 0.7. So this will be 0.7, and Eona fail in both attempts will be this option, which will be 0.6 and 0.4. So 0.6 into 0.4. And for the last option, which is Gina fails both attempts, will be this route, which is 0.3 into 0.1. So 0.3 into 0.1, and this will be Eona pass will be 0.4. So we will write into 0.4. So this is our probability, all the options we have recorded, And now we can simplify. This will be equal to how much? We can calculate. This will be 0.3 multiplied by 0.9 multiplied by 0.6 multiplied by 0.4, and this is giving us 0.648. So 0.648, and for the next one is 0.3 into 0.1 into 0.6 into 0.6 again, and this gives us 0.0108, 0.0108. And the third one gives us, if we raise this, so 0.7 multiplied by 0.6 multiplied by 0.4, and it gives us 0.168, 0.168. And next comes 0.3 into 0.1 into 0.4, and this is giving the probability of 0.012, 0.012. Now we can add all these probabilities, and this will be, we will write 0.648 plus 0.0108 plus 0.168 plus 0.012, and this is resulting to we have done some mistake, I think, so I will double check. So 0.648, 0.0108, then 0.168 plus 0.012 is resulting to, I'll double check, I'll calculate again. I think so we have done mistake in the first one. 0.3 into 0.9 into 0.6 into 0.4 is equal to 0.0648. So we miss 0 here, so it is 0.0648, and now our calculation will be hopefully correct. 0.0648 plus 0 point, or we can write point, 0.0108, and plus this will be 0.168 plus 0.012, and this is adding up to 0.2556, 0.2556, which is approximately equal to 0.256 up to 3 significant figures. And this is our final answer for this probability question. It was a little tricky question. Hopefully you understood this. Question number 14. Melissa is growing apple and pear trees for her orchard. She plants seeds in her greenhouse but forgets to label the seedling pots. She knows that the quantities for each variety of apple and pear seeds that she planted. The quantities are in the table below. So apple and pear, this is eating apple, this is cooking variety, eating variety and cooking variety. So 24 apple eating variety, 62 pear eating variety, and 76 cooking apple variety, apple, and 38 pear which are cooking variety. So she picks up an apple seed pot at random. A part, calculate the probability that it is an eating apple. So for eating apple, we know these are eating apple, and total apples are 24 plus 76. So successful outcome divided by the total outcomes. So it will be, for A part, it will be 24 out of 24 plus 76, which is equal to 24 over 100, which we can simplify as 24 divided by 100 will be equal to 6 by 25. So 6 by 25 will be answer for A part. Hopefully you understood this. Now for B part says calculate the probability that it is a cooking apple variety. So cooking apple variety are how many? These are, if I raise the color, so these are 76 out of the total one, which is again 100. So we can write it as 76 over 100, and after simplification this will be 76 divided by 100 is resulting to 19 over 25. So 19 over 25 will be the answer for B part. Now we can go for the C part, and C part says she picks out an eating variety seed pod at random. Calculate the probability that it is an apple. So I part we will solve first. So Ci is it it's an apple will be 24. We know these are 24 out of this one, 24 out of the variety which is eating is this one, which is 24 plus 62. So we can write here 24 plus 62. This will be equal to, we can simplify this. This will be 24 over 24 plus 62 is resulting to 12 over 43. So 12 by 43 will be answer for this part. Now for the second I part is a pair. So pair are how many? They are 62 pair. So we can write 62 out of again this will be 24 plus 62, 24 plus 62, and we can simplify this and we will replace this as 62. So 62, and this will be resulting 31 over 43, 31 over 43. This will be answer for second part. Now third part is a little tricky. D part, basically D part is a little tricky. We will make the space and we will go ahead with the D part, and D part says she picks out 3 seed pods at random. Find the probability that she has at least one eating apple variety. So we will take the complement side, like for example 1 minus no eating apple, no eating variety. So we will be going for this, which is the complement. So complement of no eating variety will be containing at least one of the eating apple varieties. So no eating will be what? We can write 1 minus no eating, and not eating is if we total not eating, this will be not eating is this one, which is 76 plus 38, which is not eating, not eating, and this will be 76 plus 38 is equal to 114. So basically not eating is 24 is eating. 24 is eating this one, right? And no, not eating we will calculate like this one. Not eating will be 24 are eating. So not eating are how many? Total are 200. So 200 minus 24. 200 minus 24 will be how much? This will be 200 minus 24 will be equal to 176. So 176 are not eating apple varieties. It should be apple and not eating. She picks, and probability that she has at least one eating apple variety. So not apple and not eating apple, both will be included in this one, which will be 200. Total is 200. So apple is 24. So not apple and not eating will be 176. So 176 we can take for the first, we have to take 3, right? So 176 out of 200 will be for the first one, and for the second one, 1 is less because we have already taken 1. So 175 out of 199, and for the third one it will be 174 out of 198, and this is what we need to calculate. So we can calculate, this will be 1 minus, in brackets, 176 over 200 and multiplied by 175 divided by 199 and multiplied by 174 and divided by 198, and bracket will be closed, and this is equal to 191 over 597. So 191 over 597, this will be the final answer for this question. Hopefully you understood each and everything. I will just reduce the size of this one to adjust it, and this is the question for this one. Keep in mind we used complement for D part, complement of that not eating. Now question number 15, and question number 15 says the probability that a seagull lays a certain number of eggs is shown, and the probability is shown in the table. Number of eggs 0, 1, 2, 3, 4, and more than 5 or more than 5 is also shown, and these are the probabilities. What is the probability that A part, a seagull lays more than 4 eggs? So more than 4 eggs, just we need to check from the table, and this one is easier part. More than 4 is this, which is 0.1. So our answer will be 0.1 for this. It is simple, straightforward. And for B also we need to just check answer from the table. The seagull lays no eggs. No eggs is 0.1. Again this is 0.1, so answer will be 0.1. This is also done. Then C part is a little tricky, which we need to understand. And C part says 2 seagulls lay a total of at least 4 eggs. Total of at least 4 eggs. And we need to calculate the probability of these 4. So again we will be considering for the complement, so not laying 4 eggs we will be considering, and that will be total should not be equal to 4. So what are the options that, so we will be taking 1 minus not 4 eggs, not 4 eggs. This will be the probability which we'll be checking. Now not 4 eggs options can be, both are 0, no egg for first, no egg for second. And next probability can be, first one is 0, second one, first one is 0, second one 1. This can be probability. Or next can be 1 and 0, opposite of this we can take. And next will be 1 and 1, we can take the probability, and 0 and the second one 2 we can take, and 2 and 0 at the same time we can take. Then 3 and 0 or 0 and 3 we can take first, 0 and 3, and next will be 3 and 0. This one, and then 1 and 2, 1 and 2 we missed, right? So 1 and 2, and that will be 2 and 1. So these are the probabilities which we can take, all the options we have taken. from 0 to 3 we have taken all the options, and these are the probabilities we will be writing for this. For 0, 0 is what? 0.1 multiplied by 0.1. Okay, so I will be just adjusting the size of this one, and we can write here. So now the probabilities for 0, 0 will be 0.1 into 0.1, 0.1 into 0.1, which will be resulting to 0.01. So I'm taking 0.01, and next will be 0 and 1, and 0 and 1 will be 0.1 multiplied by 0.2, so it will be 0.02. And then next will be 1 and 0. We are done with this. Now third one, 1 and 0. So 1 and 0 will be 0.2, and 1 and 0, so 0.1. So this will be 0.02 again, 0.02. Then next will be this one done, 1 and 1. So 0.2 into 0.2, this will be 0.04. So we can write plus 0.04, and this one also done. Next is 0 and 2. So 0.1 and 2 will be 0.3, so it will be resulting to 0.03, 0.03. And the next probability is 0 and 2 and 0. So 1 2 3 4 5, 1 2 3 4 5, 5 we are done with. Now 2 and 0. So 2 is 0.3 and 0 is 0.1. 0.3 and 0.1 will be resulting to 0.03, so 0.03 again, and this is also done. Then 0 and 3. So 0 is 0.1 and 3 is 0.2, so it will be 0.02, 0.02, and 3 and 0 will also be 0.02. Next we can arrange it like this one. So next is 0.3 and 3 and 0 we have done. Then 1 and 2. 1 and 2 will be what? 1 is 0.2 and 2 is 0.3. So it will be 0.06, 0.06, and the last will also be 0.06. And we will adjust their sizes as well, and this one. And we know we need to just add the probabilities, and we can add all these probabilities, and this will be our answer. 0.01 plus 0.02 plus again 0.02 plus 0.04 plus 0.03 plus 0.03, and then plus 0.02 and plus 0.02, and then plus 0.06, and last one plus 0.06, and this is resulting to 0.31. 0.31. So we have to take the complement as we discussed here. So we will be taking 1 minus 0.31, and this will be 1 minus answer will be giving us 0.69. So 0.69 will be answer for this part. Hopefully you understood this. This was a little tricky question in which we have taken complement in C part. Question number 16. A football player calculates from his previous season's results that the probabilities that he will score goals in a game, number of goals, and the probability 1, 0, 1, 2 or 3 or more scores, and these are the probabilities given. Assume that these probabilities apply to the current season. A part, find the probability that in a game he scores at most 2 goals. So at most 2 goals mean it should be lesser than 2. So what can be the options? Options are 2 goals, 1 goal, or 0 goal. So probability for scoring 2 goals is 0.2, and the probability for scoring 1 goal is 0.3, and no goal is 0.4. And we can calculate, this will be 0.2 into 0.3 into 0.4, and this will be resulting to 0.024. Basically we need to add the probabilities, we are multiplying, we need to add basically here. And this one, if we rewrite, okay, 0.2 plus 0.3 plus 0.4, and this is resulting to 0.9. so 0.9 will be the probability for scoring at most 2 goals. Now for B part, find the probability that in a game he scores at least 2 goals. So at least means it should be more than 2 goals or 2 goals. So we will be doing B part. What are the options? It is 2 goals or 3 plus goals, more than 3 goals. 3 or more than 3, probability is 0.1, and for 2 it is probability 0.2. so we can write 0.2 plus 0.1, and this will be equal to 0.3. This will be the probability for scoring at least 2 goals. Now C part is a little tricky. We will be doing C part carefully, and you will have to understand this C part. So C part says what is the probability that in 2 games he scores at least 3 goals. So it should be 3 goals. So at least 3 goals will be what? It can in 2 games. What are the options possible? The possible options we can write here are 0 and 3 plus and 3 plus and 0. And then we can write 1 and 2 and 2 and 1. And then we can write 3 plus and 3 plus, and then 2 and 2, and then we can write 2 and 3 plus and 3 plus and 2 also. And next we can write 1 and 3 plus, and last will be 3 plus and 1. So these are the possible options which we can get for this, and we'll be adjusting this in size. So this one, now we can write the probability of 0 getting 0 is 0.4, and 3 plus is 0.1, so this will be 0.04. so we can write 0.04 plus again 0.04, and plus this will be 1 and 2. For 1 it will be 0.3, and for 2 it is 0.2, so we can write 0.06, 0.06, 1 and 2, and 2 and 1 will be also same, so 0.06, plus 3 and 3 will be 0.1 into 0.1, so it will be 0.01. and then we can check for 2 and 2, 0.2 into 0.2, that will be 0.04. and then we can check for 2 and 3, so 0.2 and 3 will be 0.1, so it will be 0.02, and 3 and 2 will also be same, 0.02. then last we can check is 1 and 3, so 1 will be 0.3, and 3 is 0.1, so 0.03 plus once again 0.03. and now we can adjust this size, and these are the probabilities which we have written over here. And now we can add these probabilities, 0.04 plus again 0.04 plus 0.06 plus 0.06, and then plus 0.01, plus 0.04 plus 0.02 plus again 0.02 plus 0.03 and plus 0.03, and it is resulting to 0.35. This will be the probability for 2 games, at least 3 goals. So this was a little tricky question. Hopefully you understood this question. Question number 17. The diagram shows an archery target that is divided into 3 regions by concentric circles with the radii that are in ratio 1, ratio 2, ratio 3. A part, find the ratio of areas of the 3 regions in the form A ratio B ratio C, where A, B, C are integers. So we need to find the ratio between 3 areas. So ratio they have provided is 1 ratio 2 ratio 3. So we can write 1 ratio 2 ratio 3. This is the provided ratio. If we consider radius of inner circle, which is this red one, we can take this as R. So if this is R, second will be 2R, which is including red and white, and the third one, which is bigger circle, which is including other 2 circles as well. So all 3 circles will be 3R. So we can take these as radii, and we can take small area of the small circle, and the area of, we can take medium circle, and then we can take area of the large circle. So if we write these areas, we know area is equal to pi r square. This is the formula for pi r square. So in this formula we will be replacing, so this will be pi into, if r we are taking as this one, so first will be pi r squared and second will be 2r, so we can write pi into 2r square, and for 3r we can write pi into 3r, and this will be square, and this will be, and these 2 circles will be including the inner one. So I'm writing for you including inner circles. So including inner, and this will also be including inner. So this is how we can understand this, and I'm just adjusting this over here, and these are the areas which we found. Now these are basically the formulas which we will be applying, and we can find the area. Now A part we will be solving. These are the basics which I have written for you for your explanation. Now we can start solving A part, and A part says the ratio of areas of 3 regions. So small area will be area of small circle, as we discussed, is pi r square, and this is this area of the small circle. Now area of the medium circle we can write as pi r 2r square, pi into 2r square, and we need only white portion, so we have to exclude the red portion, which is minus pi r square. So we are excluding, this is the red portion which is bullseye, so we are excluding that one. And then when we will be solving this will be pi 4 pi, we can write 4 pi r square minus pi r square, and this will be equal to 3 pi r square. This will be area of white circle, which we have taken as medium, and large circle, area of the large circle will be what? This will be pi into 3r square, pi into 3 r square, and minus we will be subtracting the inner two circles, which is if we directly solve only pi into 2r square, this will be inner two circles. Now if we solve this one, we will be getting 9 pi r square minus this will be 4 pi r square, which is equal to 5 pi r square. These will be the areas, and I will be adjusting this to the suitable size over here for you. And now we can find the ratio of the small ratio, medium ratio, large will be what? This will be, we can write these areas, these three areas, which is pi r square. This will be pi r square. The ratio second will be 3 pi r square, and the large one will be 5 pi r square. And we can cancel pi r square, and pi r square. So remaining will be what? Remaining will be 1 ratio 3 ratio 5. This will be our final answer for A part. Hopefully you understood this. Now we can go through the B part, and B part says, B part is over here. B part says the probability that an arrow will hit the target is 4 by 5. If it hits the target, the probability of it hitting any region is proportional to the area of the same region. B part, calculate the probability that an arrow will hit the bull's eye. So B part, before solving B part, I will just fix it so that we will be getting space for the whole question. Okay, now B part will be here. B part is first we need to take the if it is hitting the target, so hitting target probability is 4 by 5. So target, hitting the target will be 4 by 5. So not hitting will be 1 by 5, remaining probability. And they are saying hit the target, calculate the probability that an arrow will hit the bull's eye. So hit the target is 4 by 5 and multiply by bull's eye is the smaller circle, which is 1 out of the total, which is 1 plus 3 plus 5, which is equal to 9. So 1 out of 9. So we can write 1 out of 9 over here, and we'll be multiplying. This will be 4 over 5 9 are 45. So this will be 4 over 45. This will be answer for B part, which is hitting the target at bull's eye. And this will be the answer which we have written over here. And next, C part. In C part we have the two arrows are short. Calculate the probability of these events. Number one, they both hit the bull's eye. So if we go through C part, both hits the bull's eye. C part 1, both hit the bull's eye. So that will be hitting bull's eye is 4 by 45, which we just calculated here, and we will be using this. So first arrow hitting bull's eye, second arrow hitting bull's eye. So this will be the probability, and we can calculate. This will be 4 over 45 and multiply by 4 over 45, and this is equal to 16 over 2025. So 16 over 2025, this will be the probability for hitting bullseye. Now the second part is saying the first hits the bullseye and the second does not. So hitting bullseye is 4 by 45. So we can take first one, hitting bullseye will be 4 by 45, and not hitting bullseye, the remaining probability will be 41. over 45, and this will be resulting to 41. We can change here this one, and this is equal to 164 over 2025. 164 over 2025. This will be the probability of one hitting bull's eye. This is done. And the last part, which is part 3, we can solve that part as well. And basically this is the third part, which is saying at least one hits the bull's eye. So this one we can use complement for this. So that will be 1 minus all not hitting bullseye. So 1 minus not hitting bullseye, not hitting bullseye. So that will be what? That will be 1 minus first one not hitting bullseye, 41 over 45, which we have taken over here. So the second not hitting bullseye will be 41 over 45, and this will be the probability which we will be finding. And we can take it as 1 minus 41 over 45 multiplied by 41 over 45, and this will be resulting to 344 over 2025. This will be the probability for this one. Hopefully you understood each and everything. This was a little tricky question. There are complexities involved in this, so these type of questions are very nice practice for your exam. So you should go through these type of questions, as many as possible. And we can go through the next question. Question number 18. Question number 18 says the letters of the word hypothetical appear on plastic squares that are placed in a bag and mixed up. A square is randomly selected and replaced before another is taken. So calculate A part, probability of 2h. So probability of getting 2h. If we check, this one is h and this one is h. So 2 out of total letters, if we count all the letters, are 12. So we can write it as 2 by 12, and 2h second also h will be, again it will be 2 by 12. So randomly selected and replaced. Selected and replaced mean it will remain probability same for both. So that's why we have taken for both cases 2 by 12, and this will be multiplied. It will be 4 over 144, which we can simplify as 1 over 36. This will be the probability for A part. Now for B part, B part says P probability 1 tail, 1t, sorry, not tail, 1t. So we will be taking t. T is here. This one, basically head and tail are there in probability questions, so that's why I was confusing. So this is t. There are 2 t's in this one out of 12. So we can take the option we can take is what? First, probability of 1t. Probability of 1t will be this one. For the first question also better if we write here probability of 2h is equal to this one. We can move it a little, and this is equal to this one. Now probability of 1t is what? Is 2 over 12, because there are 2 t's, and the second one will be not t. So if I explain it, like for example, I will explain here probability of t and not t, 2 options, and then first not t and the second one t. So these are 2 options. For first t is 12 2 by 12, and not t will be 10. So excluding t there are 10 letters, so 10 by 12. Similarly, this will be 10 by 12 and this will be 2 by 12. And we can calculate this probability, and this will be equal to, this will be 2 over 12 into 10 over 12, and plus this will be 10 over 12, 10 over 12 multiplied by 2 over 12, and this is equal to 5 over 18. 5 over 18 will be the final answer for this B part. Hopefully you understood this as well. Now we can go through the next C part. C part says probability of a vowel. So vowel are which letters? Vowel are probability of vowel. Probability of a vowel. Vowel letters are A, E, I, O, U, I, O, and U letters. Out of these letters, what can be the probabilities? So first one will be vowel, and second we can take not vowel. So one of them is vowel, so this is not vowel, and plus second case, this one not vowel and the second one vowel. Now we can take the probability of vowel. How many vowel are there in this hypothetical? We are having O is vowel, this one, then E is vowel, then I is vowel, and A is vowel. So there are 4 vowels and the rest are consonants. So we can take vowel will be 4 by 12 and not vowel are 8 by 12, and plus this will be 8 by 12 and this will be 4 by 12, and this one we need to calculate. And if we calculate, this will be 4 over 12 and multiplied by 8 divided by 12, plus this will be 8 divided by 12 and multiplied by 4 divided by 12, and this is resulting to 4 by 9. So 4 by 9 will be our probability for this section. Hopefully you understood this. So this is our question which we are done with. So this one, hopefully you understood this question. Question number 19 says Mr. and Mrs. Hilliam plan to have a family of 4 children if babies of either sex are equally likely to be born, and assuming that only single babies are born, what is the probability of the Hilliam children being 4 girls, 3 girls, and at least 1 girl? For A part, 4 girls, we can understand like this is a girl, 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 and girl. So for this one it will be 1 by 2, 1 by 2, 1 by 2, and 1 by 2. These will be the probabilities. So probability of 4 girls will be like this one. So we can multiply these, and this will be 1 over 16. This will be the probability. This is straightforward part. Now B part is saying 3 girls. So 3 girls can be different options, like we can have first girl, second girl, third girl, and the boy, and we can have girl, girl, boy here, and this one girl, or it can be girl, boy, girl, and girl. And the last option which we can have is basically this can be boy, girl, girl, and girl. So these are the 4 options which we can have. So for this one, for each one we can write like this one. So 4 options will be of same thing, which is uh, which is this one, which we can write here 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. This will be equal to what? This will be 4 into 1 over 16, which is equal to 1 by 4. So this will be the probability for 3 girls. Now the C part says at least one girl. So for at least one girl, we will be taking the complement. We will be taking 1 minus no girl. So no girl will be what? This will be 1 minus all girls is this one. 1 minus all girls, not no girls, all girls. So 1 minus all girls probability is 1 by 16. So 1 minus 1 over 16 will be 15 over 16, and this will be the probability for this question. Hopefully you understood this. This was simple question. Now this is question number 20, which is a little complicated. Question 20 says a card is randomly taken from an ordinary pack of cards and not replaced. This one is important. So this process is repeated again and again. Explain with calculations how these probabilities are found. A part, probability of first card is a hurt, which is 1 by 4. So probability of first card is hurt. So first hurt will be what? This will be, there are total 13 hearts in a pack of card which is containing 52 cards. So this will be 13 over 52, which we can write as 1 by 4, which is the answer required, which we are done with. And now we can solve the B part, and B part says probability of second card is a hurt. So second card hurt probability can be what? It can be first hurt and second hurt, and the second option can be first is not hurt but the second one is hurt. So this one, first not hurt and the second hurt. So probability will be 13 over 52 for first head, and for second head it will be 12 over 51 because one is gone out, which is not replaced, and plus not head, this one not head will be 39 over 52 multiply by 13 over 51, and we can calculate this probability, which we can check. This will be 13 over 52 multiplied by 12 over 51, plus this will be 39 over 52 and multiplied by 13 over 51, and this will be equal to 1 by 4. So which is required. We have done this part also. So B part is done. Now we can go to the C part, and C part says the probability that third card is a heart is also 1 by 4. This one is a little tricky. You need to understand this. C part, probability of third heart. There can be different options. So it can be third heart will be first heart, second heart, and third also heart. So the second probability will be first not hurt, second not hurt, but third one is hurt, and this can be the probability. Then next probability can be first one not hurt, but next one or both hurt. So this is hurt and this one also hurt, and the last one will be what? Last one will be first one hurt, then not hurt, and last is hurt, like this one. So hopefully you are understanding this. So I will adjust the size, and then we will be writing the probabilities. And probability for first heart is 1 by 4, which we have already calculated for first heart, this one in part A. Now for second heart, second also heart will be what? Second heart will be 12 over 51, because 1 is gone, and third heart will be 11 over 50, so 1 less in each case. And first not heart will be 13 over 3 by 4. Basically we can write 3 by 4, and because first heart is 1 by 4, so first not heart will be 3 by 4. This is how we have taken. Second not heart is 38 by 51, and third heart will be 13 over 50, because 1 is less and this one. So this 3 by 4 hopefully you understood, because this one is 1 by 4. First heart will be 1 by 4, so first not heart will be 1 minus 1 by 4, which we are getting 3 by 4. Hopefully this point is clear. Now for this one, first not heart and the rest 2 heart. So first not heart, which is 3 by 4, and rest 2 heart will be 13 by 51 into 12 over 50. This will be, and the last one, which is first heart, which is 1 by 4, and second not heart will be 39 by 51, and the last will be 12 over 50. So this will be the probabilities which we have written. Now we can adjust the size so that we can show here, and these are the probabilities. Hopefully you understood this. Now we can calculate. Denominators are all same, so I'm separately multiplying denominators. 4 into 51 into 50 will be equal to 10200. So I will write here 10200, and plus this will be 10200, plus this will be 10200, plus this will be 10200, and then we will multiply the numerators separately. So 1 into 12 into 11 is equal to 132, so this will be 132. And for the second one, it will be 3 multiplied by 38 multiplied by 13, and this is resulting to 1482. So this will be 1482. And the third one, if we multiply the third one, 3 into 13 into 12 is equal to 468. So 468. And the last one is 1 multiplied by 39 multiplied by 12 is giving us 468 again, 468. Now we have to add the numerators. 1 I will write here, denominators are same, so we are copying denominator, and numerators will be 132 plus 1482 plus 468 plus again 468 is giving us 2550, and if we type this one, 2550 over this will be 10200, we will be getting 1 by 4, and this was the required answer which we are done with. Hopefully you understood this. This last part was a little complicated, and you need to carefully go through these probability questions for your exam preparation. And I just wanted to mention here that these are exam preparation questions. If you want to understand the concept of probability, for that one we have uploaded another video which is just for clearing probability concept. So you should go through that video first, and then you should return to these questions. This video is for exam preparation and practice only. Concepts, I have uploaded another video for concept clearance. Hopefully you understand this. Question number 21. Susie has just taken up golf and she buys a golf bag containing 5 different clubs. Unfortunately, she does not know when to use each club and so chooses them randomly for each shot. The probabilities for each shot that Susie makes are shown in the table, and this is the table shown: right club, wrong club, and good shot and bad shot. So a part, copy and complete the table. This is easier, just we need to check. This is 2 by 3 and 1 minus 2 by 3 will be 1 by 3, so this will be 1 by 3. Similarly, this is 3 by 4, so 1 minus 3 by 4 will be 1 by 4, so this will be 1 by 4. So a part we are done with, which was completing the table, and the B part says use the table to calculate the probability that for the first 2 shots both are good. So B part, I part is both should be good shots. So there can be options that right club with good shot, and the second shot is also right club and good shot. So these can be the 2 options. Then there can be other options, like for example right club and good shot, but this is wrong club and good shot, this one. And third can be wrong shot and wrong club and good shot, and right club and good shot. So reverse of this one we have taken over here. And then the last one is that wrong club and good shot, and second also wrong club and good shot. So these are the 4 options which we can have. We will be writing probabilities for these 4 and then we will be adding them. So for right good is what? Right, there is only 1 out of 5 clubs. So there are 5 clubs, 1, 2, 3, 4 and 5 clubs. So out of these 5 clubs, only 1 is right. Say this one is right. So 1 out of 5 is right and 4 out of 5 are wrong. So we will take 1 out of 5 for the right one, and which is good. So for right good is 2 by 3. So we will multiply this by 2 by 3 and this will be the probability. Then right good again will be 1 by 5 into 2 by 3. So this portion we have done. Now we will be doing this portion. So plus right good will be same as this. We will copy 1 by 5 into 2 by 3, and the second portion is wrong good. So wrong, as we discussed, is 4 by 5. So 4 by 5, because 4 clubs are wrong, only 1 club is right one. So multiplied by the good shot. So wrong and good shot is probability of 1 by 4, which is here. So 1 by 4 we are writing here. So these first 2 are done. Now we'll be going for the third one, which is wrong. Wrong club is 4 by 5 and good shot is with the wrong club, good shot is 1 by 4. So this will be multiplied by 1 by 4, and right club is 1 by 5 and good shot is 2 by 3. So we will be writing 2 by 3. And now the last one, this one, wrong club, wrong good shot. So wrong club, there are 4 wrong clubs out of 5, and multiply by good shot, and good shot with the wrong club is 1 by 4. So 1 by 4, and the second will also be same, which we have written over here. Hopefully you understood this. This is a little tricky question, and I'm trying to explain in detail, as much detail as possible. Hopefully you are understanding. I will be waiting for your comments whether you are understanding or not. Now we can multiply. This will be 2 over 15. I have multiplied only this portion, and then this portion will also be 2 by 15, so I will write here 2 by 15, and plus this will be 2 by 15, and next will be 4. We can cancel basically, or we can write 4 by 20. For your understanding, my writing this one as 4 by 20, plus this will be 4 by 20 into this will be 2 over 15, plus this will be 4 over 20 into this will be 4 over 20 again. Now we can add these all. It will be 2 over 15 multiply by 2 over 15, and we can write it as 4 over 225, plus this is lengthier calculation, so that's why I'm breaking it into pieces. So 2 over 15 multiply by 4 over 20, so this will be equal to 2 by 75, and plus next is 4 by 20, again it will be 2 by 75 because it's the same thing, and next will be what, this will be 4 over 20, and multiply by 4 over 20 will be resulting to 1 over 25. And now just we need to add these all. This will be 4 over 225, and plus this will be 2 over 75, plus 2 over 75, and the last one is plus 1 over 25, and this is resulting to 1 over 9. This one is the answer for B part 1. Both are good. Now the second one, at least one is bad, so this is simple. We can take the reciprocal. So second part will be 1 minus no bad or all good. So 1 minus all good will be what, this we have already calculated this one, 1 over 9, so we can take 1 minus 1 over 9, which is equal to 8 by 9, and this will be the probability for this question. Hopefully you understood this. Now we can go through the next question. This question is interesting also and very difficult also, so you should be careful for this. A sleepwalker, a person that walks in their sleep, gets out of the bed and is 5 steps away from his bed door. He is equally likely to take a step forward as he is to take 1 step backwards. So A part, calculate the probability that first 5 steps he is at his bedroom door. So calculate the probability that after 5 steps he is at his bedroom door. So I have drawn this, basically sketched, or you can say I have inserted this situation for your understanding. Now after 5 steps, if he is taking the forward steps, 1 step will be this one, and second step will be this one, third step will be this, 4 steps, and the 5th step will be this one. Now probability for taking this forward step will be what, 1 by 2, and again probability for taking forward step for each one will be 1 by 2 because they equally likely. So these will be the probabilities, and we can multiply all these probabilities to get answer for A part, and this will be equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 2s are 32. So 1 over 32 will be the probability for A part. Hopefully you understood this. So what I will do, I will write here A part answer, which I will be just writing here 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 5 times, and this is equal to 1 over 32. So 1 over 32 is the final answer. I'm just erasing to utilize the space because I have to explain the B and remaining part of the question, and I'm just using this space so that I can have space for explanation. So I will be placing answer for A part over here. Now we can go ahead with the B part, and B part says what is the probability that after 5 steps he is only 1 step away from his bedroom. So only 1 step away will be this location. So if he is taking steps, like for example, if he's going 1 step back, which is like, you can say this will be 1 step back, then forward 1, this will be like 1 step, then second, third, fourth, and fifth. So he will not be reaching, even if he is taking 1 step back, he is not reaching at this location. So if he is not taking back step, so he will be reaching to the door. So there is no chance that he will be reaching at this location. So we will say for B part probability is 0. So we will write for B part probability for 1 step away will be 0, and I have explained you how we have written this probability. Now for the C part, which is a little difficult and you need to understand this, they are saying what is the probability that after taking 5 steps, he is closer to his bedroom door than to his bed. So closer to door than his bed after taking 5 steps. So there can be different situations. First situation which we will discuss is that he's taking all 5 steps forward. So 1, 2, 3, 4, 5 steps, and he's closer to the bed. And this situation I'm writing here, and this situation will be what? This will be forward, 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 and forward. So all 5 forward, and he will be closer to the door. And this situation, you remember, we have just discussed in part A, and this is the probability, which is 1 over 32 for this one. So I'm writing here 1 over 32. This is the probability for this situation. What can be the other situations? So we will discuss the other situations as well. Other situations will be, I'm just arranging it properly over here. Okay, so other situations can be 1 step back, like for example this one, 1 step forward and then back 2 steps, then third step, 4 step, and 5 step. So this will be forward, back, forward, forward, and forward. Now this B, we are shuffling at different locations, and we will be getting different options, like it will be like this one, and then this B we can shuffle somewhere else, like for example over here. And this B we can shuffle at the beginning also, like over here, then F, 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 and F, and at the end also. So F, 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 and backward will be this one. So what we have done, we have shuffled B at different 5 locations basically. So these are the 5 locations where we can shuffle, and for each one probability will be same because there are same options, like half probability of going forward, half probability of going back. So in each case it will be 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So 5 times. So each case it will be 1 over 32 probability for each case. So I am writing 1 over 32 for each case, 1 over 32 for this case, 1 over 32 for this case, and 1 over 32 for each case. So it will be 5 probabilities, 1 2 3 4 5 times 1 over 32 and plus this 1 over 32. So the probability for this will be what? This will be 5 times 1 over 32, and in this one we are adding this 1 over 32, and this will be resulting to what? This will be resulting to 1 over 32 and plus 5 times 1 over 32, and this will be equal to 3 over 16, 3 by 16. This will be the answer for this question. Now first I will arrange this one, and then I will explain the final point for this question, that why we have not taken more than one step backward. So like for example, this is our probability. So this will be, we can arrange this over here and reduce a little as well. So hopefully you are able to understand this, and this is the, so what I will do, I will further reduce this and I will place here, and this is our final answer for this question. Okay, I am done with this. Now I will explain that we have considered one step back, but we have not considered 2 step or 3 steps back. Now let us consider we are taking 2 steps back. So if we start from here, and if we are taking 1 step back over here, so we will be reaching, then second step will be this one, third step will be this one, fourth step will be this one, 5 step will be this one. So we will be away, like for example, if I start from here, 1 step back, so second step 2, 3, 4 and 5. So this will be 1 step we have taken. This option we have considered in these 5 options. We have considered this 1 step back option which we have taken, but more than 1 step option we have not taken, because if we will be taking more than 1 step, let us take 2 steps. So 2 steps will be here, then third step, fourth step and fifth step. So we will not be able to reach beyond this point, so we will be away from door. In that case, that situation we are not allowed. If you go to the question, they are saying closer to the bedroom than the bed, so bedroom door than the bed, so this distance will be more than the bed. So we are done with the video. This is basically probability difficult questions. So this is a set of 2 videos. One video is the video in which I have explained the complete basics and the concept. If you are not clear with the probability concept, you can go through that video. And if you want only exam practice, you want to prepare for good results and your concepts are already clear, then you will be going through this video again. You can go through again and practice as much as you can. Hopefully you will be able to improve your result. And don't forget to recommend this channel to your class fellows and friends, and introduce this channel to your class teachers. And don't forget to subscribe the channel and press bell icon so that you will be getting notification for incoming videos as well. Thank you very much for watching. Take care. Bye.